This is ISI MSQE 2019, last set of video for the MCQ. So here is a sequence defined as follows: x1 x0 equal to 1, xn equal to summation of j equal to 0 to n minus 1 xj for n greater than equal to 1, then the value of the expression they have asked. So now for n greater than equal to 2, xn is summation of xj, that is x of n minus 1. If I just reduce 2, so this limit, so I got one extra term xj. So that is 2 into x of n minus 1. And so we get x0 equal to 1, x1 equal to 1, x2 equal to 2, x3 equal to 4, x4 equal to 8, x5 equal to 16, and that's keeps on going. So xn equal to 2 to the power n minus 1. So for n greater than equal to 1. So therefore this is the summation j equal to 0 to infinity 1 by xj equal to 1 plus 1 by 2 to the power j minus 1. So 1 plus 2 equal to 3. So the answer is C. Next is 28. So what is the value of p does the following quadratic have for more than 2 solutions? So now it is a quadratic of x, and the only way we could do more than 2 solutions, if the left hand side is 0, LHS is 0 irrespective of x. So we need p square minus 16 is 0, p square minus 4. So all these coefficients separately equal to 0. So solving them, this will give us plus minus 4. This will give us p equal to 0 or 4, and this will give us 4 comma 1. So this is the only thing which is common in all. So answer is 4. Next, 29. So consider a square with the vertices ABCD shown in the following figure, and call a pair of vertices of a square adjacent if any connected by an edge in the figure. So we have 4 red, blue, green, yellow. So how many ways we can see the color ABCD in this? Okay, so let's position the number of ways in which the color used and then odd. So if we use 4 colors, then the condition clearly satisfies that there are 4 factorial ways, 24 ways to do this. If we just use 3 colors, so 4C3, that is 4, and then 3C1 ways of choosing the repetitive color, and 4 ways of choosing the vertices, repetitive color and vertices. So 4 cross 3 cross 4, 48. Now if we have just 2 colors, so 4C2, 6 ways, and 2 ways of coloring the vertices, so that 6 into 2, so 12. So final answer is 24, 48, 12. Option number A is correct. Now the last one. So 2 players P1 and P2 are playing a game which involves filling the entries of n into n matrix where n greater than equal to 2 is an even integer. Starting with P1, each player takes turn to fill the unfilled entry in the matrix with a real number. The game ends when all entries are filled. P1 wins if the determinant of the final matrix is non-zero, and else P2 wins. Player I winning strategy is irrespective of what the other player I is doing, so wins by the strategy. So which one is true? So consider the following strategy of the player 2. So P2 selects column 1 or 2, C1 or C2. So whenever P1 fills the entry with one of these 2 colors, so P2 immediately fills the same entry with the same row in the same column, same row, same column. So P1 actually does not fill the entry in the first two columns, and P2 fills an arbitrary value in any of the empty position of the other columns, like C1 and C2. So with this strategy, column 1 and 2 will be identical and hence linearly dependent, as first is the decider of the second. So as a result, that the determinant will be 0. Okay, so player 2 has the winning strategy. So the answer number B is correct.